Buongiorno, everybody, and welcome. Thank you for taking the time to come here and partake in this backgrounder for Identity for Developers 101. My name is Vittorio Bertocci. As you can hear from my accent, I'm based in Washington State. It's 15 years. I give a presentation. I say this every time, and every time it works. Thank you, guys. It makes me feel very good. And I work in Auth0 as an architect. In the last 15 years, I've taken as a personal mission to make identity more digestible for developers, both by contributing to make tools simpler and finding ways of explaining this. This year, I have the honor and privilege of being the track lead for the brand new developer track at Identiverse. And while discussing with Andy how to run the track, he suggested that I do a backgrounder, something that you can use for deciphering what you will hear in the other sessions in the developer track. This is a 101, and I see a lot of luminaires and big wigs in here. So unless you're here for the show, you're not going to learn anything. This is a 101. So if you already know about development and identity, you might have a better use of your time in room on the other side, room on the other. That just for giving you a bit of a warning. That said, modern identity. What is modern identity? Before getting into that, I want to relay a small anecdote. About 1 year ago, I was in the house of this gentleman, Dave, who's like Dale. He's a historical figure in identity. We've been going in the same circles since 2006, more or less. And we were at his party, and at a certain point blank, he tells me, Vittorio, I hate you. So I go, okay, what's going on? What happened? I look around left and right, and I ask him, is this drink poisoned? And why? And he was telling me that he was in a meeting with some of his C-level suit friends, and they were telling him, but why are we bothering with this auth thing? Why can't we do this modern authentication like the Microsoft guys are doing? At the time, I was working in Microsoft, and Dale credits me for having how to say, popularized the term modern identity. Of course, he's giving me way too much credit, that's not true, but still, he gives me that fault. But I think that it's a really good way of seeing that modern identity really is a very nebulous concept. It really doesn't mean much. It means something different depending on what is your baseline. Whatever you were doing before, which is different from what you're doing now, what you're doing now is modern identity. So I want to try to define it. I'll just go and describe some of the tools that we are using today, and then we'll call that modern. And then next year, we'll call something else modern. Works? Yep. Very good. All right. So as I mentioned, this is a backgrounder, as in you will use this for deciphering the other talks in the developer track. So it's going to be very basic. And who attended the introduction to identity? You will hear some of that overlap. But here, you will hear it in the context of making things very concrete for developers. So we'll do a little demo, which is always a bad idea at Identiverse. But it's a very simple demo, so hopefully. And we'll try to really make these very practical. And yeah, pretty much it. So the idea is that you know about development. You might not know about identity development, but you are familiar with developer concepts, and you have some idea of what identity means. Like, I'm not going to tell you the difference between authentication and authorization. So I'm going to first define what definitely isn't modern authentication. Then I'm going to look at the most common patterns that make a difference, that actually impact the development practice when you're building and protecting an application. And then I'm just going to explore a bit of the components that come into play when you use modern identity. I see no objections. Very good. So this is what you normally do like you have two ways of being non-modern in your authentication practices. One is to use passwords, and the other is to use Kerberos. So let's start with passwords. Passwords are a very easy trick. The idea is that digital identity of your user is just the set of attributes that define the user in the context of the functionality that the application wants to deliver. So if it's a tax office, your social security number. If it's Amazon, it's the last 10 books that you bought. So it doesn't have to be exactly your identity, as in like knowing who you are. It's just a set of attributes. And the credentials, the thing that you present when you sign in, actually, let me pull out my toys. That's basically what you need. Like you just show up your credentials, and your credentials tell to the system to pull out the corresponding attributes. It's as simple as that. And again, in the spirit of keeping things moving, I'm not going to tell you all the many different ways in which this thing is wrong. But instead, I'm going to move things slightly forward. Now, think of a case instead in which you'd take this kind of approach and you'd move it in the context of a business. So say that you have the same set of applications, actually the same application, but you have more than one, and you use all of those in the context of a business. Here, I'm having a harder time operating all these because this podium is more of a surgical implement. There's like stainless steel, which is good for wounds and similar, but if I leave a mouse, as you can see, whoop, it's magic. So think of a case in which you have one context, like one perimeter of some kind, and you have these applications running all in the same context. Now, what happens is that that's exactly what went on in the industry when disparate sets of applications for personal use ended up being all in the same, under the same roof. And so at that point, we saw the emergence of this concept of directory, which is this cathedral that lives in the middle of your enterprise, where you can centralize all of this functionality. And then at that point, whenever you need to access one application, the idea is that your user, at the very beginning of the day, they sign in this central place, and then thanks to that, they just access everything else. And all of this happens at the network layer. Let's say that for the sheer fact that you exist on the network, identity comes with it. So this is all the non-modern authentication. Now, what makes the first step toward modern authentication? The first step is what my former boss, Alex, likes to say, dissolving perimeter, which is having this perimeter around your resources and your users is no longer something that you can afford. Let's say that now you use software as a service, you have mobile users, like you cannot expect people to work from the exact building where you have your network hardware. And so as a result, you have like this loose collection of applications that live around. So you can no longer rely on network software to do this. So now we'll see what to do about it. The idea is that this idea of having a centralized place for dealing with identity, or at least a place whose goal is to deal with identity, even if it's not the only one, it's actually a good idea. The main challenge to this is that you want to be able to do this without relying on the network layer. So what happens is that you can still have a component in your system that deals with identity, but now instead of relying on the network, you rely on higher level protocols. You describe the transactions that tie together users, applications, identity providers, and similar. You place some kind of interface on top of your resources. Here, I'm choosing OpenID Connect because it's fashionable, but it could be SAML, it could be any protocol that you want. And then at that point, you establish this idea of what we call trust. Let's say that you have your application that trusts an identity provider to say the truth about a particular user population. And then at that point, you can offload the authentication function. And here is the part where usually our fault, identity fault, we skip a passage. We just say, OK, done, that's it. Instead, let's look in practice what that means. What that means typically is that you have your application that somehow needs to establish some kind of relationship with your identity provider. That's the first step. If you remember what we did earlier in Kerberos, I didn't have to do any of that. Let me rebuild my perimeter. I didn't need to do any of that because there was only one game in town, the domain controller. So whenever I created an application, the application automatically trusted the identity provider. But now, in which I actually have a choice. I don't have to talk only to this identity provider. I can talk to anyone that plays the role of identity provider. Now there is this idea of establishing trust, which literally means that the software that I will use for protecting my application, which is typically some kind of library that sits in front of your app, or a capability of a hosting platform that you use for running your application, needs to decide to accept identities from a certain identity provider. So there is a first step in which you retrieve what we call metadata. We'll see that in the demo. And then once you've done that, once you have a user, actually, let me use a different color. Once you have your user that attempts to get a token in here, the idea is that this software will intercept your call, will turn that call into a request for the user to sign in for your particular app, and will redirect you to your identity provider, whose location is known because when you establish the trust, you got that location. So this is the main difference. If you are used to do classic authentication support, and you are used to deal with username and passwords in your application, or if you're used not to worry at all because Kerberos did everything, this is the main difference. You need to place something in front of your app. You need to configure this app to trust the identity provider, and then at runtime, this thing will do various redirects. Now, how do you actually use the identity provider? You use it by getting back what we call a security token. Like once you successfully authenticate with the identity provider, which will do whatever technique it wants to do without having to follow any protocol for authenticating the user. That's a private matter between the identity provider and the user. What you get back is an artifact which represents the successful authentication that just occurred. And this artifact is called a tokens. If I'd have gifts to give away, it would be yours. But I don't have any budget, I'm sorry. Come to the booth and we'll find something. All right. The idea is that you have this artifact, which is, again, proof that successful authentication occurred. It's signed so that I'm sure that you heard in the other presentations what digital signatures are. But just in terms of like value, the idea is that the signature proves the provenance of this thing. It's coming from the provider that you trust, and it protects things from being tampered in transit. So now whatever is inside the token is something that the application will believe because it trusts that part. And so the idea is that we get this artifact, which in this particular flow is actually coming down typically in a little form with some JavaScript that on load will post it back to your application. And here your middleware, the same middleware that converted your first request into a sign-in request, will actually validate your token, like check signatures, check expirations, check provenance, check audience, check all of that stuff that, again, I hope you heard in the other presentation. And in exchange, it gets a tasty cookie. Let's place the cookie in here. And now the cookie represents your session, like something which now I no longer need to do this dance every single time as long as my cookie is around, various techniques for making it sliding, expiration, and similar, then I have my session. And in fact, there is also another cookie between the identity provider and the application. Now, the presence of this other cookie is important because here there is another trick. Now, imagine that this user now wants to access this other application. Let me make it exceedingly clear that it's a different app. Let's do this one. Okay. Say that the user wants to access another app, and this app also trusts the same identity provider. Here you do the same dance, you get redirected to the identity provider, this time with an ID of the other app. But now I already have a cookie. So barring exceptional circumstances, like more consents and similar, then I will get back a token right away. And now I can post this token directly and get another cookie, which I will also change for sake of clarity. And then at this point, I achieved the famous single sign-on. Let's say that instead of having to rely on the domain controller and everything being under the same roof, I just leveraged the fact that I use these session cookies and similar. Anything mysterious so far?
So for the second time, you just reuse the cookie that is out there. You don't ask again for the credentials or anything. You just reuse them and then get the cookie token.
That is exactly right. For the recording, the gentleman said that we are, for the second time, we are reusing the presence of the session cookie with identity provider, and this allows us to achieve single sign-on without giving the credentials again. Now, it's true that we don't give the original credentials again. The thing that might happen is that the second app might, for example, ask for multi-factor authentication. Or it might be accessing things that I didn't consent for yet. So at that point, you might still see something. But the idea is that at least you will not see the username and password again. Great. Yes, sir?
Do you recommend storing token in cookie?
Do I recommend storing tokens in cookies? I'll come back to that after the session.
So it's a separate cookie.
Yeah. No, it's a longer discussion with, and I'd needed to bring things up that I didn't introduce yet. But I promise that we'll talk about it as soon as we are done. Also, this was just an excuse for me to drink. You weren't supposed to ask anything at all, but that's fine. Luckily, you asked something I knew. There's always a risk of the opposite. OK, so this is really the main pattern. And depending on how much white you have in your beard, if you have a beard, you might acknowledge that this thing was also SAML, which is not particularly modern, but believe it or not, for people that lived only in the world of Kerberos, it's brand new. 1 month ago, I was in Oslo, and I was doing a workshop for a customer, and I had 40 architects which never, ever used anything but Kerberos. So as William Gibson say, the future is already here, but it's not universally uniformly distributed. So what is modern, again, is relative. OK, so let's see how this thing works. No, not. So close. So close. OK, so the idea in all this is when you want to use a service, an identity provider of any kind, typically you need to describe the situation to your service before you can take advantage of it. So in particular, in order for your application to turn around and go to your provider and ask for a token, your application has to be known to the identity provider. Mostly because the way in which we establish all of these things. You have seen I've just moved the tokens around. We call those tokens bearer tokens because the only requirement for using them is the same requirement as using $20 for buying something. If you find those $20 on the floor, they are just as good as the one that you got in your salary. It's just like the sheer possession of that thing allows you to use it. So as a result, we need to be ultra careful about where we send this stuff, which means all of those legs always occur in HTTPS. And when we configure applications, we have to be very explicit with the identity provider about where we want to get tokens back. Given that it's all done by a redirect, we have to declare exactly what is the address that we want to get back. And also lots of other potential settings we want to do. The substance, the concrete point is I need to register my application before doing everything. So here I already registered the app, but I just want to show you the entry of this application. Typically, and here, of course, I get my salary from Auth0, so you're going to see Auth0. But the idea is that functionally, you're going to get exactly the same stuff from pretty much any provider. Some provider will have like a management console instead of a web app. Some other will have only config files. But conceptually, the functional steps are all the same. Am I speaking too fast? Raise your arm if I'm speaking too fast. No, great. Thank you for catching me while I'm like this with. Huh? You're a true friend, Brian. Just like Dale. Yeah. So let's go in our applications. And here I have like a super simple entry for my app in which the important parts are the client ID, which is the identifier that I used for, I got assigned from identity provider when I registered the app, which I will use in the configuration of my middleware. And then, somewhere I have the address at which I'm expecting stuff to come back to. Like, basically, I'm telling the identity provider, once you're done and you need to send a token, please send it here. And if at runtime I try to get it in a different address, I'm not going to get it. Like, this is going to be strictly enforced. And then the other part which is important is for my application to establish trust with my provider, I need to give to my provider, to my application, the address of a document, which is called the discovery document, which substantially contains all the coordinates that a piece of software needs for consuming my identity provider. And here, thanks to awesome Chrome plugins, you can see the content of this document, which is clearly not designed to be consumed by humans or by like, some people that spend weekends writing specifications can consume this, but if you have a social life, usually you look at this and it doesn't make a lot of sense to you. But for me, if I don't have a lot of social life, it actually makes sense. And here you can see, like just to shine a light on specific parts. For example, here there is the address of the endpoint to which my application needs to redirect when it's time to authenticate a user. And let's see, later on, there are things like pointers to the keys that will be used for signing the tokens that I will issue. So this guy is the address where I will find the keys. So those are the kind of things that you can expect in this document, but luckily all you need to know as a developer is the address. And then you just plug that thing in your application. So let's do exactly that. So here I have an ultra simple application, which comes straight from the templates. When you use Visual Studio and you create an application, by default, you get exactly the code that you see here. And yes, I see my colleagues from Auth0 which say, oh, why are you using Visual Studio? We are supposed to use Node. Sorry. It's just like, for demos, it's easier because like, it's all point and click. Then, of course, when the real game come on, no, I know. I'm like an old dog, so new tricks. I've been doing that thing for 17 years. So and this is powerful. Like you can use any programming language you want, and you'll see exactly the same. So it doesn't matter whether you use one or the other. You use whatever works for you. So the idea is that this application has a number of libraries that I already pulled in. And in particular, in this context, there are some which are relevant. And I have one library which supports OpenID Connect, which depends on a library which can parse the particular type of tokens that we use in here, which are JWTs. And then I also have a library designed to deal with sessions, cookies, and similar. So all off the shelf. And if you do this in Node, you have the same. If you do this in Java, you have the same. If you do this in Go, it's a bit harder, but it's still doable. And the idea is that I just initialize these things very easily basically all I need to do is to specify the address of that endpoint that I described earlier, and then I specify my client ID. And this is all I need for doing all the little dance that I described earlier. So let's do a little dance. Here I have a proxy which can capture traffic. And once I hit the 5, basically I just end up think of a flow that we have seen in here. I made that first call and I got redirected. So now I'm redirected there and I'm being authenticated with my identity provider. And if I look at the trace, here you can see exactly what happened. Remember what I said earlier about having to be a developer in order to follow this thing. So don't blame me if I show you code. So here I just tried to get the root of my application. My application is configured to accept no anonymous user, so that's why I get bounced right away. You can see in here on the bottom, maybe you from the back can't, so let me try to zoom better. Yep. That very action is a 302. And here I have what that arcane stuff is a message that represents my sign-in. So if I actually go in my in the request that I'm actually doing, so when I'm executing the 302, and here there is a view which shows me all the parameters. You can see that I'm sending the client ID. You can see that I'm sending the redirect URI that I configured earlier, and everything else is like arcane jargon used by OpenID Connect, which I don't need to go into the details to, but the idea is this is a sign-in request. Now, funnily enough here, this is something that often people don't tell you about, so let me show you. Here there's a little history of what happened. Like those are that's the first request that I did. When I tried to get to my to the homepage, you can see that there are like a couple of other requests in the middle before I got my answer back. Those requests are because it's the first time that I hit my application. So my application turned around, and before doing anything, it asked to the identity provider using the metadata discovery endpoint all the details that are required. And then it used those details for crafting the answer, and then that's why I got the answer. So that's true. That's really how it works. OK, so let's go back to this guy. And let's hope it didn't time out, because I blubbered. And here, I just happen to have these two options because I configured my identity provider this way, but doesn't matter. Here is like I might have even just one. And what happens here is that once I sign in, I get bounced back. And here I just place a little breakpoint so I can look at what I received. So here I have a little piece of console where I can write code on the fly. And I'm just dumping the list of attributes, claims, from what I got from identity provider. Now you have my personal email. Please do not abuse it. I should have thought this through. And here there's like a set of claims that I received. All these claims are identity claims in this case, but I could have just as easily had authorization information. So the idea is that the application will get whatever claims are required to perform its function from the identity provider, and you can pretty much carry any information. And as you'll hear in some of the sessions in the developer track, very often these things will be attributes, roles, groups, and permissions, and similar. And just to see in details what that means, like if you use a middleware like this one, the one that I'm using, you don't really need to sweat the details. Like, as you can see, if I would not have dug into the trace, you would have been none the wiser of what was happening in here. But if you wanted to troubleshoot and similar, it's useful to know what's behind the scenes. So if I actually look at what was sent here, like at the end of my sign-in, and once I received my token, here I can actually retrieve the bits of a token. which are in here. And as we said, this token is in JWT format. And there is this nice little website that you can use for picking inside the tokens. Like the tokens are not encrypted usually, they are encoded. So the fact that it's not easy to read doesn't mean it's encrypted. Don't make this mistake. It's surprisingly common. And here you can see that once decoded, here I have pretty much the same content that I've shown you, plus some lower level information, which is typically used for validating the token, which is not shown in the app because it normally isn't pertaining to the user identity, it's more of on what happened. All right, so now you can say that you have seen a trace. Isn't that exciting? Okay, so this one is the sign-in. Now, for what concerns the more basic, like the more lower level primitive, the more fundamental area, all the things that I did earlier used OpenID Connect, which is a protocol which was devised to help you to do sign-in, and it's built on top of OAuth. OAuth is a protocol which doesn't do authentication. It's a framework, actually, not even a protocol. It's a framework designed to help you to deal with delegated authorization. So it's a very, very specific scenario. Very often people try to stretch it beyond that scope, but that was the reason for which it was conceived. And so ultra quickly, the idea is that because you cannot not know about OAuth, so unfortunately I've got to dig to this level. The idea is that you have this particular scenario in which you have, say, one application like LinkedIn that wants to consume Gmail APIs for sending invites for joining LinkedIn to all of your contacts. And I use real names just because it's easier to understand, but this doesn't mean that that's the way in which those providers work. So don't quote me on that. Imagine they are like from a different dimension. And in the classic way in which LinkedIn was used to do this, that's true, it was used to do this in the past, LinkedIn would ask you for your Gmail credentials. And then LinkedIn would use your Gmail credential directly with APIs. And this achieved what you wanted to do, which was to access those APIs for sending mails to all of your contacts to invite to get to LinkedIn. But it had the problem that you were sharing credentials to a third party, which is very, very, I mentioned, very bad. And also, you had no way of containing what LinkedIn could do. Credentials would give LinkedIn absolute power on your Gmail. So OAuth was designed, kind of like emerged organically, as a way of solving this problem. And again, I'm expecting that you heard about from the introduction to identity, so I'm going to go pretty fast on this. Here, the idea is that if Gmail wants to support third-party access, delegated access to its APIs, they can implement this artifact, which we call the authorization server, which is designed to provide a leg for having users grant consent for this operation to happen, and it has another endpoint which is used for giving you the actual tokens that the client will use for accessing those APIs. So in practice, that means that when the user is in a session with LinkedIn, how we establish this session out of scope, they might have signed in using whatever mechanism they want. If now they want to gain delegated access, they can craft a request to the authorization server, a request which looks very similar to the one that I've shown earlier for sign-in, but in this case, instead of asking for an identity token, I will ask for an access token. And here, I will have the opportunity of first, sign in if I'm not signed in. But as you can see, now the credentials go in the right place. They don't go at all through LinkedIn. So good. And after that happens, and after I grant consent for the particular operations that LinkedIn declared wants to do, just send email. Typically, the authorization server will send me back an artifact, which we call an authorization code. This is just a note to self. User X granted the consent for application Y to access these kind of permissions. And then this code gets bounced to LinkedIn. And then LinkedIn, just like we did the registration earlier, LinkedIn needs to have registered itself as a client with the authorization server of Gmail. As in the process, it will have been assigned a secret, a way for the application itself to prove its own identity. And then all these will be used for hitting the other endpoint of the authorization server. And as such, you send these couple of things, and the outcome is that the authorization server will. Is there anyone from Windows here? Why is this thing happening? See, when I project, this thing happens and makes my life more difficult. Projector issue. Very good. Deflection is a very powerful young Jedi. So the idea is that once you successfully present your code and you authenticate yourself as an app, you get back a bunch of tokens. Again, I'm oversimplifying. You have seen this token earlier, the token for identification. It's optional, but often you want to get it because otherwise you don't know what happened. You get an access token, which is the thing that you really want to use. And that is, in fact, the thing that allows you to access the Gmail APIs without having to have shared your credentials, and we've reduced the scope so that now that access token grants your application only the ability to send mails to contacts, as opposed to do other things that you are not OK with LinkedIn doing. And this other token which we send in there is what we call a refresh token. It's just an artifact for renewing access tokens, which are typically short-lived, without having to do any interaction with the user again. Now, this thing is, like chronologically, came before the scenario that I've shown earlier. Like auth got adoption before OpenID Connect was even conceived. Again, OpenID Connect is on top of this. But I've shown them in the opposite order because in terms of frequency of scenario, the sign-in is the one that is far more common. And very often, you just look at things in OpenID Connect and they don't make a lot of sense. Like, why am I calling my application the resource that I'm getting access to, the client? Like, it's a resource, right? The reason is that all of that, now the applications in OpenID Connect are modeled after this model. The only difference is that instead of using this flow, which was devised to get access tokens, for access tokens, you use it for getting ID tokens. And ID tokens are the things that you can use for authenticating. So mostly you need to understand both things, even if you just want to do sign-in. But it's important to keep in mind that when you use pure auth, you normally use it just for calling APIs, exactly in the scenario that you have in here. And now that makes things even more confusing because auth tells you how to do this for third parties. But there is no specification that tells you how to do it for first parties, which is fine because for first parties, in theory, you can do whatever you want. If you have your own client and your own API, go ahead, do whatever you want. But the thing is that most people, rightfully so, they don't want to reinvent the wheel. So they want to use the same middlewares that you used, or even for third parties, the same security models and similar. And so what happens is that they use the same principles also for calling first-party APIs. But when you call first-party APIs, typically the token that you want go beyond just the access. Typically, that's the only token you get. So you also want identity information. So online, you'll find lots of contrasting takes on this for people confused about this particular fact. So whenever you look at auth applied to a first-party API scenario, remember that there will be things that you will have to do on top of auth for making it work for first parties. And these themes will be developed during the developer track. No pun intended. So with these scenarios, these topologies that I described, basically you can model everything. One of the things that make OpenID and auth more modern than SAML, despite of the fact that SAML is still based on redirects, is exactly this power. for the fact that sign-in is built on top of the ability of getting tokens for APIs, now you can combine this stuff in whatever way you want. You can have all sorts of clients that run on user devices, that run on the server, that are interactive, that are non-interactive. You can combine calling APIs with sign-in with web apps. The idea is that this trick of going back to a central location to get the token and then accessing the resource with the token grants you unprecedented flexibility, which you cannot achieve with traditional means unless you are in your little walled garden of your local network, which if you are, prepare to be disrupted because it won't last. Now, super quick, some of the components that we touched on. Here is just a laundry list of things that you need to think about when you do development with modern identity. Some I didn't mention it, but all the sign-in flow that I described could have described the SAML just as well. And you might have heard something like 5-7 years ago that SAML is dead, but 7 years later, if you don't have SAML in your list of features, you are likely to lose your RFP. So it might be dead, but keep it around. And I just described the scope that you can achieve with OpenID Connect and OAuth2, so won't go much into the details. JWT is really the de facto standard. Whenever we use a format for tokens, we don't always need to use a format. Access tokens, in theory, can be shapeless. But in practice, if you look at most of the public offerings, you'll see that JWT is used pretty much everywhere. And then there are emerging other standards, in particular, very compact stuff for like networks with poor bandwidth. But for the time being, they are just like still a rounding error. JWT is everywhere. Identity providers, here the example I gave you is Auth0. Auth0 is one example of the identity as a service, whereas many others in the market. And again, we all have our strengths and our differences, but the function that we play is pretty much the same. As long as you implement those protocols, you can use whatever form you want. So you can even have servers that run within your company, which was what was common 7 years ago, 10 years ago. So ADFS is a good example of that. It's like software that runs on your local network and has the capability of running all the flows that I just described. And then if you go lower in the scale of granularity, you can actually use SDKs. Like there are exceptionally good open source products which allow you to build your own little identity provider, which will give you complete flexibility about how to do this. On Friday, little plug, I have a session about extensibility, and I will go in details about the difference between those approaches, strengths, and weaknesses. But the thing that is common with all of them is you always have to go and pre-register the app in the way that I described. So from the point of view of a developer, in practice, you always need to do that. In terms of application integration, the demo that I did used middleware, which basically is a library which integrates with whatever web technology you're using for hosting your application, and somehow sits in the middle of requests, intercepts things, and makes things happen for you. There are other approaches, such as you could have a gateway, which is the choke point for which all of your requests go, and then from the gateway to your application, you might have other means of securing the call. And yet another method is to use what I call fabric, as in if the hosting that you have has some feature that automatically inject support for authentication, as it is the case for some of the big cloud providers, you can do that as well. That is on the resource side for protecting your web API or your web app. On the client side, there are also SDKs which simplify that little dance of getting an authorization code and exchanging it for a token, saving refresh tokens, automatically using refresh tokens for getting access tokens. And there are a number of libraries that are specific for the vendor because that scenario is conducive of being specific. Like the spec doesn't tell you exactly how refresh tokens should be used. And it's a specific information about the vendor. So often the vendor will give you an SDK which takes advantage of that knowledge. There are also completely generic ones, like the app auth or the identity model from the same guys as identity server. Those operate at the protocol level, so you can use them pretty much with anyone who supports that protocol, but they are a bit harder to use because, of course, now you can't use just like the job to be done. Like you can't just say sign in. You typically need to say, I want to use the implicit flow with form post, which is a bit more arcane. And super fast things that you can't do with either Kerberos username and password, so domain of modern auth, you can actually, given the fact that you're doing redirects, just iterate the process and have identity providers that act, in fact, as multiplexers. So places where you can actually manage your relationship with other identity providers that are deep in the chain. And then at that point, you get the problem of helping the user choose which identity provider to use. And so here you have different techniques. And the one that you see in here is what is familiarly called NASCAR, as in you have little buttons for every identity provider that you want. There is another one which is very popular, which is identifier first, in which your user enters the username, and somehow the username is used to infer from where they are coming from. So one thing that is, if you develop in modern auth, you need to take into account. Of course, this thing is typically at odds with SSO, because SSO tries to never show anything to the user. So at that point, you need to shoehorn the user in a particular account, and if you shoehorn them in the wrong account, then the calls to support start being nasty. And then there is this other thing about consent. We have seen that auth is all designed on top of this idea of consent, which once again, you don't have in traditional flow. Double-edged sword, good for viral adoption, because users can be self-determining and decide what they consent to, what they don't consent to. But whenever the user has to make a choice in business environment, that is a choice that might go wrong. And when the choice goes wrong, is calls to your support people, and every call is money. So your administrators will be of two minds on this thing. So key takeaways, mostly modern identity is redirects. You do redirects all the time. Is one of the things that when you go to the customer and you say, customer, modern identity is awesome. They go, what about these redirects? And we have seen good things and bad things about it, but mostly good things. And again, I tried to keep this thing as generic as possible so that it applies to pretty much any of the vendors that you find on the market today, because like functionally, we are kind of like all in the same ballpark. Whoops. Then here is the track for the developer track for Identiverse. The speakers made an excellent job to create really, really good content. So I highly recommend that you keep these into account as you do your, and it's on Twitter, so you can find it. Did you take a picture? Fantastic, very good. Okay, and if you want to dig deeper into this, like unfortunately, all the introductory sessions happened before or during this session, so you lost them, sorry. But you can just go in the recording, which will show up in a few weeks. Then, if you are not too annoyed by my accent, today we just put online 4 hours of me blabbering about this. It's basically like our onboarding process for our new employees. We just made it available for everyone. So if you want to dig deeper, you can like take a lot of coffee or whatever stimulant you choose. I don't judge you. And then all the icons that you have seen me using, again, today we are open sourcing them. So if you want to use them as a starting point for doing your diagrams, again, they are very generic. There is nothing of zero specific there. So you can go to that address. And I'm easy to recognize. So if you see me in the aisles, you can grab me gently. And we can talk to your heart content. And if you want to send me a mail, I'm very unlikely to reply, but feel free to send it. But I'm more responsive on Twitter, mostly because you can shame me there. And that's it. Thank you.